All right, now that we're recording, this is week 2 of business math. It is 12/27 of 2022. Excuse me. And I hope everyone had a great Christmas. Got what you want, Santa visited, all that other stuff. We went through the same thing that we always go through, which is my wife stressing, saying, oh my gosh, we didn't get everybody everything they ever wanted forever and all time, and nobody's going to have anything to open. And then there's so many presents when we take them over to the kids' house. There's so many presents that you can't even see the daggum tree, between them buying presents and us buying presents and the other grandparents buying presents. And then, aunts and uncles, poor kids don't even have room for all the stuff. But hey, at least she's worried about the kids getting what they want, right? Oh, Taylor is here. Put Taylor in real quick. And I do always ask, if you can turn on your camera, it would be awesome. I like seeing Roy and Laura, just so I can have somebody to talk to. Not Riley. Oh, I'm teasing. See, so are you still in the hotel room right now?
I am. I literally just got into it, so I'm
Where
very nice to be able to just sleep and relax.
Where are you stuck at?
So I was staying with family in Venice, California, but there's no flights out of LAX that are able to go through the Southwest. So I'm in Ontario right now, and then I fly out tomorrow.
Ooh, okay.
It has been crazy.
Yeah, I got stuck. I don't know if any of the older people remember when JetBlue had a plane go down. This is probably, I don't know, 20, 22, 23 years ago. And I'd flown into Oklahoma, and then the plane went down, but they let us get on the plane in Tulsa and take us to Dallas. No, let's get on. No, it happened sometime. I don't remember. Okay. Anyway, I got from Dallas to Atlanta, and then they stuck us in Atlanta, saying they grounded all the JetBlue flights. And so I was stuck sleeping at the airport. But they let us go from the crash happened. They still let us get on from Dallas to Atlanta, and then just were like, oh, never mind. So that was cool of them. But at least, they hit me up with a hotel room and all the other good stuff. It just took some doing. Okay, so did we get my chapter 3 assignments open back up? As I missed them, do my family question. I believe I did check, Glenda, and if not, in fact, I could check real quick for you. Bradley. Oh, no, wrong button. Yes, I got your chapter 3 done, Glenda, so you should be good to go. All right, well, let's jump in it. Hi, Taylor. I see Taylor. See Joanna. Dominique, glad to see you here too. Let me share my screen. Now we'll be flipping back and forth between this screen and then my whiteboard that I use on a separate tablet. So I'm going to skip chapter 4, checking accounts. That should be pretty easy for everybody. The one I really want to concentrate on right now is chapter 5, and that is using equations. This is kind of our beginning point of algebra. Most of you have probably seen this stuff back in high school, or it's some other time. But this is kind of where we start getting into real meat and potatoes of it. So I'm trying to find a place to put my right there. Okay. All right, so let's look at chapter 5. Now, on these problems here, And these are easy. You'll be able to just look at them and know what the answer is on a few of these. But let's go over some of the terminology. When you see a letter in a math problem, that is called a variable. It is a letter used to represent a number. So in fact, it is still a number. It's just an unknown number, and it has to follow the exact same rules as any other number would. So it's not special. It doesn't follow any separate rules. It's just, you know, we threw a letter at it so we can represent it as something, because we don't know what it is. On this one here, we can pretty much easily tell that D minus 37 is equal to 40. So we can say D is equal to 77, right? 77 minus 37 is equal to 40. Pretty easy to figure out. But we're going to do the algebra way. So as I grab my tablet here. Okay, everyone should be able to see my whiteboard right now. There we go. Oh, stop. I don't want it to cover up everybody's face. There we go. So it was D minus 37 is equal to 40. Now, the way we do this thing algebraically is our mission in life right now is to take that D, that variable, and by itself on one side of the equal sign. Okay. We wanted to say D is equal to something else. That's our whole point. What is keeping it from being by itself is minus 37, right? Now, one of the things you need to remember, whatever they are doing on that is you need to do the opposite. Now, that's one of the rules. Also, you have to keep everything balanced. Consider this like a seesaw with the equal side sign being the fulcrum, okay? If you have one kid on this side that weighs 90 pounds, you put another kid on this side that weighs 90 pounds, it stays balanced, okay? Our job is to keep that seesaw balanced. So if we put another kid that weighs 90 pounds on it, there's two kids on one side, you have to put another kid on the other side. I guess the long story short of what I'm trying to make is whatever you do to one side of the equal sign, you have to do the exact same thing to the other side of the equal sign. All right. So, and you have opposite of what they're doing. So I know this kind of seems counterintuitive. So they're subtracting 37. Rewrite this here. D minus 37 is equal to 40. They're subtracting 37. So to get that 37 out of the way, I add 37. And that gives us 0. I add 37 to this side of the equal sign. That gives me 77. This goes away. D is equal to 77. Not hard at all, right? Any questions on that? Okay. It gets harder, but we got to walk before we can run, right? So let's look at the next problem. All right, so this one here was using subtraction. Now, if this said D plus 37, then you would subtract 37 from each side, right? And let's just put this in here. We say D is equal to 77. 77 minus 37 is indeed equal to 40, because once we get to where that's at, we understand that D is no longer unknown. D has a value, and it is 77. And submit the answer, and it should tell if we got it right. All right, all right. So must have been some ones I did before another class. That's funny. All right, let's look at this. 7 divided. Okay, remember, a fraction is the same as a division problem. So This is 7 divided by 3 is equal to 85. Z divided by 3. I don't know why I said 7. Z divided by 3 is equal to 85. Okay. And that it's the same as this. Now we're not going to use this right here, but just remember a division is the same, or a fraction is the same as division. Okay. So can someone tell me what is, since they're dividing, what is the opposite of division?
Multiply.
Multiply. Yes. Melissa, look at you go. So if they're dividing by 3, we multiply times 3, and we do the same thing on both sides. Okay, which means 3 divided by 3 is 1. So the 3's just kind of go away, right? They leave us with a Z right here, 1Z. We don't have to write the 1 down. 240, 255. Okay, and the way you check that answer is, and we could have went back to the other one. I should have done that, but once we have a value for Z, okay, we can go back into our original equation that they gave us, and instead of putting Z, we put the number for it. And we see if that's a true statement. Let me see if that is a true statement. Okay, so that is a true statement. So 85 is indeed equal to 85. We're good to go. Again, switch screens here.
So you multiplied it to 5, and I think it's 55, so it's 165.
Oh, is it?
Oh wait, no, wait, I'm looking at the wrong one. No, you're right.
Okay.
Yeah.
No, I could be wrong. I am wrong. All right, so you know what? And this is when I say, hey, everybody, don't be a dunce like me and pull that out. 3 times 85, 255.
Isn't it 255?
Yeah, you entered 85 as the answer.
Oh, okay. Well, yeah, because I'm a knucklehead. There we go. Now we got it. Now this one, they do 2 things at once. All right. So R over 5 plus 37. Now, the way I used to teach my high school students to do this is, one of the ways is when we have more than one thing to do here, I want to start as far away from the variable as possible and work my way toward it, if that makes sense. Now, there's a million ways to do this and get it right, and 10 billion ways to get it wrong. But to make it simple, they're adding 37. I'm going to go ahead and subtract 37. And if I do it to one side of the equal sign, I do it to the other side. 37 minus 37 is 0, so that just goes away. That is that 51, guys. So we're left with R over 5 is equal to 55. 51. I just can't get it right with these numbers, can I? Then, since they're dividing, we're going to multiply. Means that goes away. 255 again. So correct me if I'm wrong. So we moved farther away from that thing and got the answer. Now, there's more than one way to do this. So let's look at R over 5 plus 37 is equal to 88. Now, we could have went ahead and multiplied by 5 first. Okay, that's not out of range to do that. But when we do that, remember, we're dealing with everything on one side of the equal sign as opposed to the other side of the equal sign. So if I decide to multiply times 5 first, I have to do everything. So that goes away, but I also have to multiply that times 5 as well. So R plus 150 plus 35, 185 is equal to 440. Then I go back and subtract 185. Oh, that goes away. 440 minus 185 becomes, hopefully, 255 again. So R is equal to 255. So if you can see, you have more than one way you can do that. Just sometimes the other way is a little more complicated than you want to deal with. So that's why I said, get what you can farthest away from that variable over to the other side first. Because what we deal here with is a thing called the distributive property. All right. And let's cover that real quick. If I have something that looks like that, and I have to multiply that 5, the distributive property tells me I have to distribute that 5 through everything inside that C's. So I have to multiply it times this, and I have to multiply it times that. That's why I did what I did earlier. So that becomes 5A plus 5B. So, and like I said, if you get more comfortable with these, that's one thing, but you can see there's many different ways to do this. All right, share my screen. Get rid of, let me see, get rid of my calculator. So what do we say? This was 255 again. Okay, and you also have a read it. It'll take you, stop it now. If you hit read, it'll take you to the right chapter. If you hit watch it, they will bring up a video here.
I can only see your
Oh.
whiteboard.
Oh, sorry. You go back, I forgot to hit share. There we go. If you hit read it here, it will take you to your chapter. If you hit watch it, means I need to share my sound. It will send you a video.
Now let's consider this equation. We have t over 7 plus 8
And they
equals
may explain
9.
it better than I do.
We see that again we have two terms on the left, and we'd like to have just the term involving the t. So we'd like to get rid of the 8. We're adding 8, so to get rid of it, let's subtract 8. If we subtract 8 on the left side, we must also subtract 8 on the right side. Subtracting 8 on the left side leaves us just t over 7 on the left side. Subtracting 8 from 9 on the right side leaves us 1. So now we have an equation, t over 7 is equal to 1. This equation is simpler than the original equation, and it also has the same solution because we did the same thing to both sides of the equation.
You can see it now, can't you, Melissa? Or everybody can see it?
My screen is black. I mean, I can see you, but yeah.
Can you guys see the screen? Laura,
I
Roy, or
heard the
Riley?
video, but it wasn't like it
Yes,
wasn't
I can
playing.
see it.
Okay, let me try it again. Share screen, screen 2, share. How about now?
Now subtracting 8 on the left side leaves us just t over 7 on the left side. Subtracting 8 from 9 on the right side leaves us 1. So now we have an equation, t over 7 is equal to 1. This equation is simpler than the original equation, and it also has the same solution because we did the same thing to both sides of the equation. Now we look at this and we say, oh, we've got t over 7. I really want just t. How can I get rid of the 7? Well, in this case, we're dividing by 7, so the opposite operation, or the inverse operation, would be multiplication. Let's multiply both sides of the equation by 7. 7 times t over 7 will just give us t, because 7 over 7 is 1, and 1t is just t. And on the right side, 7 times 1 is 7. So the result of this is an equation, t equals 7, so 7 must be the solution to this equation.
They did pretty much the way I did. All right, now we're going to get a little more complicated. Look at number 4 here. We have a variable on this side and a variable on this side. Now they are the same variable. They're both C's. Okay, so that helps us out. If you had like a C and a D, then that becomes a completely different kind of equation that we're not even going to deal with in this class. So you should have just single kind of variables. So let's go to the whiteboard. Time check. All right, we're doing pretty good, I think. All right. Problem of C plus 6 is equal to 24 minus 2C. Okay. Now, once again, we want the C by itself on one side, but somehow we got them both on one on each side, right? So we need to get them all up on one side. They're subtracting 2C here, so the best thing I can say to do is I'm going to add 2C right here, which means that goes away. I'm going to add 2C. So C plus 2C is going to be 3C. Leaves me plus 6 is equal to 24. So then we're back into familiar territory, right? Then I said, hey, let's go farthest away from our variable here to try to start working our way towards it. They're adding 6. I'm going to subtract 6. 3C, that goes away, is equal to 24 minus 6 is 18. If you notice here, they're multiplying. 3C means 3 times C. So I'm going to divide by 3. Divide by 3. And C is going to be equal to 6. No muss, no fuss, right? Now, here's the way you check that. You go back to our original equation right here, and wherever you see a C, you plug in 6. So 6 plus 6 should be equal to 24 minus 2 times 6. 6 plus 6 is 12, is equal to 24 minus 2 times 6 is 12. 12 is equal to 24 minus 12 is 12. We have a true statement. It means we did our problem right. If you would have come out with anything else, if you would have come out with 14 is equal to 10 or something like that, well, they're not equal to each other. So that means you did something wrong. That's how we can go back to that original equation and plug back in our value for the variable. Okay, anybody have any questions on that? You got to unmute, Riley, if you're asking me.
When it says us to like check your like solution or anything like that, do we just put in the answer again?
Yeah, because what you have here is you have, we say the answer was 12. Let me share my screen. So we said our answer is 12. So put that in. And then 12 and 12, just kind of like I plugged it in when I wrote it out. And boom. They be
I'm pretty sure it was 6.
6.
6. Jesus, man. There we go. Keep me on my toes, guys. Keep me straight. There we go. Come on. What just happened? That was weird. Are you guys still there?
Yes.
Okay, I can't see anyone right now.
We
My
can see
computer.
you.
Okay, my computer went nutso and I can't see anyone.
I can see your screen.
Let me hit stop share. Okay, now you're back. Oh, my screen started flashing and then things went blank. It was not cool. I was afraid I was gonna have to jump off and restart again. All right, there we go. So you guys should be able to see my screen. Some reason. This is frozen. All right. Well, that was something that doesn't usually happen. All right, let's see if it comes out to looking all right. Okay. All right, we are back. And it didn't even change my answer. For some reason, it freaked out when I put the 6 in. There we go. Submit answer. Okay. So it looks like it liked it. Now we're going to skip 5. We're going to skip 6. We're going to skip 7. Although I'm going to go slowly. So if I, okay, let me say here, I'm going to go slowly. So if you guys want to go back to the video and look at them, you can, although the answers are not on this one. All right, so this one here, this is where they just kind of jump into something quite a bit more complicated, and it's in a word problem. So let's go over it real quick. An online store sells 2 types of speaker docks for smartphones, because I am going to get questions on this one. The higher price speaker dock sells for $170, and the lower price speaker dock sells for $80. Last week, the store sold 4 times as many lower price speaker docks as higher price speaker docks. Combined sales totaled $3,430. How many lower price speaker docks did it sell? Now we see the answer there is 28, but we have to figure out how to get there, right? All right. In these, sometimes I have to dumb around on them because I, don't do them but every 2 or 3 months. All right, so let's think about what they were saying. They sell 2 types of speaker docks. They sell the high price ones and the lower price ones. All right. Now they sell the number of, let's see, the higher price speaker docks, they sell for 170 each. The lower price speaker docks, they sell for $80 each. If you see, I do this whenever I do anything, I'll sit down and do it with paper or whatever, and I'll write down the information I know. We also know that they sold, that the number of speaker docks, the higher price speaker docks they sold, excuse me, I'm reading it wrong. That's what I always do. Okay. Well, the higher price speaker docks sold for 170, lower price speaker docks for 80. Last week, the store sold 4 times many lower speaker docks as they did higher price speaker docks. So the number of lower price speaker docks they sold 4 times as many. Or the number of speaker docks they sold would be 4 times H. Can we agree with that? That's where I'm getting stuck at. Okay. All right. So now we have a new value for L. L is now 4H. Okay. So if I take $170 times the higher price speaker docks plus $80 times the lower price speaker docks, which is now 4H, right? They sold $3,430 worth. And let's see if this works out. So 170H, and I have to do a little math here. 80 times 4 is 320. H should be equal to 3,430. $170H plus 320H, which would be 490 H's, is equal to 3,430. All right, I'm gonna pull up my calculator again. So I'm gonna divide each side by 490. So H should be equal to what's 3,430 divided by 490, and I should get a nice even number. Okay, so I sold 7 docks. Okay, if L is now equal to 4H, which becomes 4 times 7, right? Then our lower price speaker docks, we should have sold 28 of them. And so we did come out with the right answer. That's kind of ugly, wasn't it? Especially the way I did it. Yeah, that's kind of on me for dumbing around for a minute, going, I don't know what I'm doing. So let's look here. All right, so the answer is 28. I guess I've done it in a prior class. I never erased it. So now let's see, just out of curiosity, what they told us to do.
A candy store at the mall sells dewdrops for $4 per pound and gummy flies for $7 per pound. If they sell twice as many pounds of gummy flies as dewdrops and take in $522, how many pounds of gummy flies did they sell? Well, again, let's analyze the problem. We can come up with this reasoning. We know that the sum of the price multiplied by the number of pounds of each type of candy is equal to the total sales. Let's let x equal the number of pounds of dewdrops, and let's let 2x equal the pounds of gummy flies. Then let's write our equation. We know that the dewdrops sold for $4 per pound. There were x of them sold. So 4 times x would give us the total value of the dewdrops sold. Likewise, the gummy flies sold for $7 a pound. We said that 2x would represent the number of pounds of gummy flies sold. So 7 times 2x would be the value of the gummy flies sold. That total would equal 522. So we have the equation 4x plus 7 times 2x is equal to 522. Solving the equation, well, we can multiply 7 times 2x to get 14x. Now we can add 4x to 14x to get 18x. So our equation now is 18x is equal to 522. Dividing both sides by 18, we have 522 divided by 18. That's x equals 29. 2x then would be equal to 58. In this particular case, we asked for the number of gummy flies, and since that was represented by 2x, the store sold 58 pounds of gummy flies.
He seems to do it a lot smoother than I do. And you're going to have a couple of these. Let's look at this one. So number 10, what are we doing on time? Okay. Suppose a certain company sells regular keyboards for $82 and wireless keyboards for $115. Last week, the store sold 3 times as many regular keyboards as wireless. It's the same problem, right? If the total keyboard sales was 5776, how many of each type were? And you can go back and watch this one again because it's basically the same problem. So let's look. All right, so suppose a certain company sells regular keyboards for $82 a piece. And they sell the wireless keyboards for $115. And last week, the store sold 3 times as many regular keyboards as wireless. So 3 times the wireless is going to be equal to regular. Anybody disagree with that? All right, so then we're going to set it up. And we're going to do this in terms of W, because we want to keep them all one type of variable. You can't you can stick 2 variables in one problem, but then it becomes an impossible solution without having 2 different equations to do that. So we don't want to get into that mess. So $115 times the wireless keyboards plus the number of regular keyboards times 82. But now we know that regular keyboards are now 3W. So 82 times 3W should be equal to $5,776. Okay, just like the last one. I'm just going to go with 115W plus 82 times 3 is 246. 246W is equal to 5776. 115 plus 246, 346, 361. Then I'm going to divide, since they're multiplying, I'm going to divide both sides by 361. And I'm going to pull out my calculator and make sure I'm right. So 5 and 7, 6. 7, 6 divided by 361. So we sold 16 wireless keyboards. Now R is equal to 3W, which is equal to 16 times 3. So that's 48. So we sold 48 regular keyboards. And if I share it back here, and that's what we got, 48 and 16. I see a couple people desperately writing. Any questions? It's not as, once you do the second one, it starts to kind of become a little more clear, right? Once again, they are going to do the same basic problem here on number 11, the same basic setup. So you are the administrator of an essay contest scholarship fund. That's funny. My wife used to be the scholarship coordinator at OSUIT. She loved that was her favorite job because she got to give away hundreds of thousands of dollars every year just to people who needed it. Yeah, they didn't pay her hundreds of thousands to do it, but hey, whatever, man. Then she got promoted. So how awesome is that? Don't know why I'm telling you that. It's been a long night. This year's $64,000 college scholarship is being divided by the top 2 contestants, so the winner receives 3 times as much as the runner-up. Okay, how much will each one receive? Well, the setup is going to be the same again, guys. Okay, we have the first place person and a second place person. Oh, that is not what I wanted to do. My hand was doing things on its own. And the second place person. Okay, the first place person is 3 times the amount the second place person does, right? That's an S. And the total they're going to give away is $64,000. Okay, so once again, we go back to the second place person plus the third place person. Ah, that looks like a 5. That is an S. It's equal to 4,000. Okay, so S plus 3S is 4S is equal to 64,000 divided by 4. So the second place person gets 16,000. And since F is equal to 3S, which is equal to 3 times 16,000, to $48,000. Right? And 48 plus 16 should equal to 64, right? Roy's had enough of us. He hit the couch. He's watching a ball game right now. He's not even paying attention to us. I'm just teasing, man. So let's see if we're right. Runner up was 16,000. The winner was 48,000. Right. Once again, like I said, it's the same setup. Now, a 46-piece set of stainless steel flatware costs $128.80 at a certain store. What is the cost of dollars per piece? So that's a pretty easy one, right? $128.80 divided by 46, but they want us to set it up into an equation. But so let's just do that. $128.80. $2.80 per piece. All right. Didn't like it. It liked it. Okay. Okay, so they want us to use a ratio and proportion. Now that is, once again, that's fractions. Fractions are division problems, but they're also ratios and proportions as well. They represent a lot of different things. So if a bulk of 19,000 blouses costs $51,300, How much in dollars would 2,000 blouses cost? So let's see if I can get this one right. Been a while since I've done one of these. Now, just like the problem we did, there's a couple of ways to look at it. If we take $51,300 and divide it by 1,900, I'm going to get the cost per blouse, right? Okay. Now, the way they want you to set this up is we're going to take our $51,300 divided by 19, and we're going to that equal to an unknown cost over 2,000 blouses, right? So you have to, you set up the same ratio. Riley gave me the side eye on that one. She's like, I'm not buying it, man.
Just explain real quick why it's not why it's 19 and not 19,000 real quick, just so I can understand.
Oh, because somebody didn't write 3 zeros behind it.
Okay.
Some moron. So at this point, there's a few different ways to solve this, and I'd like to show you if I can do it. Okay. One of the ways to solve it is by cross multiplying. Is I multiply these two together, and I multiply these two together. Okay. Oh, what?
1,900, not 19,000.
Yeah, probably. If I can find out where my Zoom meeting went here. There we go. All right. Oh, one too many zeros. Let's see that. Okay. All right, so I can cross multiply. So 1,900 times X will be 1,900X. And that's going to be equal to 51,300 times 2,000. I'm gonna pull my calculator out for that one. That is 102,600,000. Divide both sides by 1,900. So 120,600,000. So X will be equal to $54,000. Now, one of the things I usually explain to math students, and this is a really good time to look at it, is does my answer make sense? Now, if you would have stick with $102,600,000 for 2,000 blouses when 1,900 of them cost 51,000, there's a big discrepancy, right? The answer doesn't make sense. So that's, but $54,000 seems to make sense, doesn't it? For another 100 blouses. Now that's not a guarantee that you got it right, but at least you're not so far off. So let's look, okay, let's do it one more way. Now remember that our job is to get X by itself on one side. So like right here, I could have multiplied both sides by 2,000. Okay, that would have went away, and that would have still given me 102,600,000 over 1,900. Leave the zero away. Is equal to X. So we would have still came out with the same answer, right? So as long as we're able to manipulate these things, all right, because this is what we're doing. If you notice, we're not really changing any values of anything. We're just manipulating these numbers to come to an end solution. Because if I go back to my original equation here and replace this X with $54,000, and if I say 51,300 divided by 1,900 is the same as 54,000 divided by 2,000, that's exactly right. That is exactly right. And so let's look at it right here. Share screen. Yes, share. And we said, what was it, $54,000? And computer says yes. And the reason I'm saying this, let me pull my calculator back up here. Come on, calculator. Is it was $51,300 divided by 1,900. That is $27 per blouse. 54,000 divided by 2,000 is still 27 per blouse, right? Okay, so I know it's wanted to get to one more problem. You guys want to stick around for one more? If you can't stick around, I completely get it. Okay, Joanna's like, yes. If you need to bounce, I get it. It's getting really close time, but there's one more I wanted to do, and it is on the next. Bloody arse. It should be on the chapter 5 quiz. It's going to be basically the same problem again, except it is gasoline. This one right here. Now, there's some different types of problems. If you have issues with them, remember, you can read it. You can, on some of these, let's go here. Not a whole lot of videos on these, but you can always ask me, and I will get back to you as soon as I can. So let's look at this one. Pitts Pit Stop sold $15,934.50 worth of gasoline yesterday. Regular sold for $3.30 a gallon, and premium sold for $3.45 a gallon. If the station sold 390 more gallons of regular than premium, answer the following questions. Now, this is going to be set up very similar to the one we did, but they've thrown us a little curveball. So let's all right, so our total sales were $15,934.50. Okay. Regular gasoline sold for $3.30 a gallon, and premium sold for $3.45 a gallon. Okay. Now, if the station sold 390, so instead, it's just a little bit different. If the station sold 390 more gallons of regular than premium, okay. So we have regular, and they sold whatever amount of gallons it is. Okay. The amount of premium they sold, make sure I'm doing this right. Let's do it like this. Regular is going to be equal to how many gallons of premium we sold plus 390 gallons. Okay, does that sound right? Okay, so this is grouped together as one number, all right? because this whole thing here is representative of R. So we got to treat that whole grouping as one number. And I know that's a little bit different than before. So $303.45 times premium plus our regular, which is now $3.30 times P plus 390. And remember, we treat this as one number here. Okay. Now, I talked about the distributive property earlier, right? And you see something like this, I've got to multiply this 330 by here, and I also have to multiply that 330 by here. Okay. I have to distribute it through everything inside those parentheses. And that whole thing is equal to 15,934.50. So now I have 3.45p plus 3.30p plus, pull up my calculator here. Did I get out of it? Well, you know, go ahead. Calculator. Okay, so 3.3 times 390. $1,287. All right. Now I have a P here and a P here. And I have this by itself, and then 15,934.50 on the other side. All right, so I can go ahead and say 3.45p plus 3.30p, which is 6.75p plus 1287 is equal to 15,934.50. I subtract 1287 out of that. That goes away. So 15,934.50, 15,934.5 minus 1287. So 6.75p is equal to 14647.5. I just plugged that into my calculator, guys. Divide both sides by 6.75. Both sides by 6.75. And I'm going to get P is equal to 2,170. So the number of premium gallons, the number of regular gallons, which is equal to 2,170 plus 390. $2,560 gallons. Okay. So let's just throw it in. Okay. We can look at it. One of those I've already answered. $2,560 and 2,170. So we were right. And the second part of the question is, if the profit on regular gas is 15 cents per gallon and our premium is 18 cents per gallon, what is the station's total profit? Well, I'm going to take 15 cents per gallon and multiply it by 2,560. Then I'm going to take, let me see, hold it. Yeah, regular is 15 cents, 2,560 times 15. 18 cents per gallon, I'm going to multiply it times that. And then I'm going to take those two numbers and add them up, and that gives you the what profit the station makes. Okay. That was pretty easy. I figured you guys would jump in on that after that. So, all right, how does everyone feel about it? Everybody feel better or worse after tonight?
For me, it's good once the equation is made, because building the equation for me on word problems is really hard. So like after you create the equation, I know what to do. But like for me to build it, it takes me a while, or I struggle with it, I should say.
And well, yeah, and word problems are always a pain. I had an old math teacher. He said we used to call them story problems, and he says they're not story problems. He said because stories start with once upon a time and end with happily ever after. He said none of these problems end with happily ever after. So okay, well, if you have any questions about anything, email me, hit the ask your teacher button, and I will get on it as soon as possible. I will be back in the office tomorrow. So I've been a little bit behind because of the holiday in, but we're going to get that all over with, except for yep, you got to get back to liking numbers, Belinda. Belinda, are you local, or where are you local, Tulsa? Stigler. Okay. The reason I ask is if anyone can make it into the office for help, get with me. We can make an appointment, and I will 100% make sure I have time to be in the office to help you guys out. So if you need special help and you want to come in and do face-to-face, that is perfectly okay with Bob or I. So, I mean, for some people, who are stuck in Venice Beach, California, getting a suntan or whatever, or people who are, I don't remember where Stigler is at, to be honest. But if you can get in, you're more than welcome. All right, everybody, I'm going to stop recording. 2.5 hours away. Oof. I'm going to stop recording.